Yeah. This is last night's homework, so you're not ready. You're just take this all in. Okay, so there's the first visual portion, an even function symmetrical to the y-axis. That second piece where I wrote this, what that gives us visually, and I'll give you some concrete examples. If I plug in if I look for f of 6, I get 1, 2, 3, 4, 5. And what this tells us is that if I plug in the opposite of that, if I plug in -6, I should also get back 5. F of 6 is 5, and f of -6 is 5. Obviously, that's happening because of the symmetry. If I were to do f of 2 isn't as clear, it's about 3. F of -2 should also be 3. And of course it is because of the symmetry. So whether you take f of x or f of -x, you should get back the same number either way. The same works for 10. F of 10 gives me -3. F of -10 should also give us -3, and it does. That's the second part. Okay? So now we'll get started on our notes. I kind of highlighted the two key features of even functions right away. Symmetrical to the y-axis, and if f of -x is simplified, it gives us the same thing that f of +x gave us. Okay? Odd functions are different, but there's still a symmetrical aspect and there's still an f of -x aspect. An odd function is symmetrical to the origin. Okay? More importantly, it looks the same right side up as it does upside down, and we'll kind of look at that visually. And algebraically, if f of -x is simplified, it's not going to give us the exact same number as the original. It's going to give us the opposite version of the original. So for example, if f of 5 gives us 7, then f of -5 is going to give us -7. I'll give you another example. If f of 3 gives us -2, what do you think f of -3 is going to give me? +2, correct. You get the opposite of the original. The even one, like we did on the other page, if I do f of 5 and it gives me -7, what other point do we know if it's even? F of -5 is going to give me also -7, correct. So even whether you plug in the positive version or the negative version, it's going to give you the same numerical answer. That's because that's symmetrical to the y-axis. For odd ones, if you plug in the opposite, you're going to get the opposite. That's because it's symmetrical to the origin. Okay? And to the point of what that visual symmetry looks like, think about the point 5,7. In the point -5, -7. You don't necessarily have to draw this, but just watch. 5, 7, and I plug in the opposite, and I get the opposite. That's symmetrical to the origin, because if I take this graph and I turn it upside down, it's going to be the exact same look. We have something in the first quadrant and in the third quadrant. If I flip this perfectly upside down, I have the point 5, 7 in the first quadrant and the point -5, -7 in the third quadrant. So the graph looks the same right side up as it does upside down. Okay? And we'll get to more of that. So if I go back to my flashcards really quickly, if we're going to have a flashcard that says even degree polynomial, we're also going to have a flashcard that says odd degree polynomial. This is not what we're learning today. This is what we already knew. What do you know about odd degree polynomials? Like a third degree polynomial or a fifth degree, Nate? Right, opposite end behaviors. And a little diagram to help you kind of visualize. That would be an odd degree polynomial. That would be an odd degree polynomials. Okay? Whereas an odd function is not limited to polynomials. Yes, polynomials can be odd degree polynomials and they may also be odd functions, but you could have an odd function that is not a polynomial at all. So any graph that is symmetrical to the origin, and any graph algebraically where f of negative x is going to give us the opposite of the original is the algebraic test. There are lots of odd degree polynomials that are not necessarily odd functions, and vice versa. There are definitely a gazillion odd functions that are not even polynomials, so certainly they're not odd degree polynomials. So we're going to think of these things as totally two separate concepts, but obviously I want to show them to you side by side so that we can highlight the differences and not get confused. Because when we say even degree polynomial, that's a different thing than an even function. Okay? Polynomials, first and foremost, have to be either even or odd. They have to be one or the other. If they're a polynomial function, they have to have an even degree or they have to have an odd degree. Whereas with functions, you can be neither. So a function could be even if when you plug in negative x, you get back the original. Could be odd if you plug in negative x and you get the opposite of the original. Or could be neither if neither happens. Okay? So here's our first example. Here's what we'll always do if we're determining, and this is algebraically. We're going to plug in negative x and see what happens. Okay? Always just plug in negative x. And then simplify. So what is the absolute value of negative x? Just x, well, provided that x is positive, right? So the absolute value of negative x is just the same as the absolute value of x. And then your minus 4 doesn't change anything. So when I plugged in negative x, this is the function I got back. Is that the same as the original? Yes or no? Yes. So if it's the same as original, then we conclude it's an even function. Connor, can I steal your calculator, please? Just because mine's on my end. So I'm going to show you visually, and you should know that this is the absolute value parent graph. How has it been shifted? What'd you say? 4 units down. So the absolute value parent graph is like that V-shaped. So here's that V-shaped shifted 4 units down. If it's an even function, which we thought it was when we did it algebraically, does it have the even function symmetry that it's supposed to have? Is it symmetrical to the y-axis? Yes. So there's extra confirmation. Okay? Number 2. Now this, for the record, do we all agree this was an absolute value function? This was not a polynomial function. So talking about degree as well here is not even a topic of conversation. This isn't even a polynomial function. Number 2, however, is a polynomial function. So just by looking at it, is it an even or odd degreed polynomial? Odd degree. But that is not necessarily going to mean that it's an odd function. It may or may not be. We have to plug in negative x to see. So when I plug in negative x, I get negative x cubed minus 4 times negative x. When I do negative x times negative x times negative x, what do I get? Is a negative times a negative times a negative going to be a negative or a positive? Negative, so that's just going to be negative x cubed. And what's going to happen with negative 4 times negative x? Plus 4x. So now when I compare that, simplified, to the original, is it exactly the same? No, so it's not even. Is it a negative version of the original? Meaning, if I put a negative out in front of this, negative version of the original, is that the same thing? Yes. So this is the exact opposite of the original. It's a negated version of the original. So opposite of original tells us that this is odd. So yes, it was an odd degreed polynomial, and it just so happens that it's also an odd function. And so I'm going to show you x to the third minus 4x on here, so we can talk about the symmetry with the origin. Okay? There's the graph. Symmetry with the origin means if I flip it upside down, I'm going to be looking at an identical graph. Agreed? That's identical to the upside down version. That's your visual representation of an odd function. Capiche? Now, let me take another polynomial function. Do we all agree that that's an odd function? Odd degree polynomial, I should say, odd degree polynomial. Does this look exactly the same upside down? No. One of the main reasons I can tell is because here we have a positive y-intercept. When it's upside down, we have a negative y-intercept. It's not the same graph. It's still an odd degreed polynomial because we have opposite end behavior, but it's not looking the same right side up as it is upside down, so this one would be neither as far as functions are concerned. It's not even because we're not symmetrical to the y-axis, and it's not odd because it's not the same right side up as it is upside down. Good? Okay. Number 3. This is not even a polynomial function. So talking about even degree versus odd degree is not a topic of conversation. This is a fractional rational function, which we will get to more of. Obviously, if it's going to be exactly the same as the original, it's going to look like this. What is the opposite of the original? How do you take the opposite of a fraction? What's the opposite of 2/3? That's the reciprocal. Opposite. Opposite just means negate it, right? So when I was looking to see what the opposite of this was going to be, I just put a negative out in front. And because it was a polynomial, I had to distribute it. This, with a fraction, if you want the opposite of the original, you would just negate it. Essentially, most often we just negate the numerator, and that negates the whole fraction. So 1 over that x squared would just, the opposite of that would be negative 1 over x squared minus 2x plus 3. That would be the opposite. Now, I don't know if we're going to get that, but that would be the opposite. You could also negate just the denominator. Another version of the opposite would be this, negative x squared plus 2x minus 3. That would be a version of the opposite as well. When you negate a fraction, or you take the opposite of a fraction, you either negate the numerator or you negate the denominator. Why wouldn't you negate both? Right, because if you negated both, now you've just multiplied by -1, multiplied by -1, so you're back to the original. So you wouldn't ever negate both. So let's see what happens. If I plug in negative x, note that when I'm plugging in negative x, I'm keeping a parenthesis around each spot where it's been plugged in. And then I'm going to simplify. What is negative x when you square it? Where'd the squared go? So negative x times negative x is x squared. What happens with the negative 2 times the negative x? Plus 2x, and then the plus 3 is just plus 3. So when you compare that to the original, is it exactly the same? Is it exact? No, so it's not even. Is it exactly opposite, meaning is either the numerator or the denominator negated? No. This one's tricky because, yes, there's a piece of the denominator that's negated, but the entire denominator was not negated. So this does not qualify as being the opposite of the original either. So this one is neither. I'm spelling neither wrong, aren't I? Whatever teacher told me I before E except after C was lying. Okay? So if I take a peek at what this graph looks like to kind of highlight graphically, now my denominator is a polynomial, so I have to keep it in parentheses. Or some of you guys use the Alg2 equals 3, but we haven't done rational graphs yet, so we're not totally sure what they look like. But did you see it kind of trace along there? It did a little curve there. I can't really see the graph very well because I've got way too much on my y-axis. So when I go back to my window, I'm going to make it from like -2 to 2. And this should show me a little bit more. Okay. Now, here it is right side up. Here it is upside down. Clearly two different graphs. This one's entirely below the x-axis. This one's entirely above the x-axis. You with me, Bo? Okay. So it's not odd. And it looks like it wants to be symmetrical to the y-axis, doesn't it? But it's not quite. This is not, if you flip this over, it's not mapping onto itself. So that y-axis is not quite a line of symmetry, so it's not even either. Are you making sense of this? Okay. Exercise 2 below. Kind of like what we did on, what I just did on the homework from over the weekend. They want us to sketch the rest of this in A to make it even. So they've told us 3 points, 0, 0, 3, 5, and 7, -2. So where should I plot another point? What do you think, Aiden? Y6. -3, 6 would be here. 5. -3, 5. Good. We're going even, so when we plug in the opposite, we should get the same thing for an even function. And then, Cameron, another point? -7, -2. And then for 0, 0, obviously, if you plug in the opposite of 0, that's still plugging in 0. You're still going to get 0. So we've got something symmetrical to the y-axis. Good? Okay. So for odd functions, it's the same first starting section, but we want to make it odd. So 0, 0, when we plug in the opposite of 0, we want to get the opposite of 0. So actually, that's just going to stay 0, 0. for 3, 5, what do you think, Evan? That's going to put it down here, right? And then we would fail the vertical line test, so we wouldn't be a function at all. When you plug in the opposite, negative 3, you get the opposite, negative 5. So plot negative 3, negative 5. Can you try the last one, Evan? Very good. When you plug in the opposite, you get the opposite, negative 7. When we complete these pictures, we still want it to be a function. And so this is a function, and supposedly it's an odd function, and we'll just confirm. If I flip this upside down, look at the before, and then look at the after, and it's the exact same graph. So that tells you have symmetry with the origin. Any questions so far? Okay, flip over. Here's an exponential function. We haven't gotten to this yet. They want to know, is it even, odd, or neither? Support your argument with numerical evidence. So plug in a number. Let's plug in 1. F of 1 equals 2 to the first equals 2. Then plug in the opposite of that, f of negative 1. We get 2 to the negative first. What is 2 to the negative first the same as? Negative exponents mean we have to move that to the denominator, so 1 over 2 to the positive first, which is just 1/2. Did I get the same thing? No, so it's not even. Did I get the opposite thing? No, so it's not odd. So therefore this is neither. If it was even, I would have gotten 2 again. If it was odd, I would have had to have gotten negative 2. This one I got neither. Think about this one. F of x is an odd function. F of 5 equals negative 2. Which point must lie on the graph of its inverse? So if this is the point 5, negative 2, what would be the inverse of that point? No, the inverse of this point. Inverse means you just flip-flop the x's and the y's, right? So the inverse of this one would be negative 2, 5, which is not an option. But because this is odd, Nathan, tell me what you were going to tell me. What's the point if I plug in the opposite, I get the opposite? Negative 5, 2 is also on the original graph, so the inverse of this point would be 2, negative 5. So here are your inverse points, and 2, negative 5 is an option. That's a tricky one. They're combining inverses on you with even and odd. Not a big fan of that question because it's extremely tricky. But subject to common core. Here is your homework. We definitely got all the key concepts, so don't worry about the fact that we didn't finish that. That's funny. Must have been a good example. I got to know that you can take our. Okay. Well, yeah. Then you already have an extra one, right?